Welcome to Science with Miss Steph. Today we're going to do the classic soda and Mentos investigation. Stay tuned. Good afternoon, everyone. Welcome to the 63rd episode of Science with Miss Steph. And as you can tell, today's science activity is going to be really fun. We're going to do a classic activity and it's going to be great and fun and exciting. For those of you who are used to being able to watch me on Instagram as well, just know that I'm only doing Facebook today. I have some adventures going on around me. Science is going on around me. Remember, I'm always teaching you that science is everywhere. And right now in my apartment, there is a really awesome person who's helping fix the electricity in my apartment, okay? And so for that reason, I need to make sure I only use one device. All right? Remember, science is everywhere, right? So I am using one device today. And so it's going to be great. It's going to be old school, right? Just like back this time last year. So, like I said, welcome, episode 63 of Science with Ms. Steph. Today you only need a few materials. You see I have three different kinds of soda in front of me. That's because I want to show you what happens with different ingredients, but you can just pick one of these three sodas. Okay. Normally, this activity is known to be done with Diet Coke and Mentos. Well, guess what? I'm going to show you that you don't necessarily have to have a specific type of soda to do this. And we're going to talk a little bit about what the science is behind why you can try various sodas. All right, does that sound like fun, y'all? So, I'm going to put two of my sodas aside, right? And I'm going to start with our classic activity, the classic activity, Mentos and Coke. Now, some of you may be wondering if I've lost my mind a little bit by doing this so close to my computer, right? Because you know that normally this can be a huge giant geyser, right? It can go up really high in the sky and make a giant mess. But I'm going to use only a few Mentos. So that means I'm going to be able to control the size of the reaction. Okay? Isn't that an interesting thing to know that you can control how big a reaction is by the amount of materials that you use and the amount of items that you mix together? So today I'm only going to use two Mentos. Hmm. Two. Doesn't that seem maybe like it might not be enough? Maybe like I'll need more? Well, guess what? I'm going to start with two Mentos inside of my Coca-Cola. And yes, this is classic Coca-Cola, okay? I'm not using diet Coca-Cola. And that is intentional. That's on purpose. Once again, thank you for joining me for episode 63 of Science with Miss Steph. And today I'm only using Mentos, okay, which you can get at, you know it, CVS, Rite Aid. You know how I am. I'm always thinking of materials that you're able to get and that they're easy for you to access. You don't have to order things online. I'm using a fresh bottle of soda. You're going to notice that there will be a sound when I open it. I have paper towel down in my bin and I have a bin, right? I would never do this activity just on my table, okay? Because it makes a big giant mess, which is kind of the cool part of it, but that's also the thing that we need to be careful about. All right, so once again, I'm only using two Mentos. Two. I'm going to add them in very quickly. I'm going to back up a little bit. And we can talk towards the end as far as why this activity works, why this reaction occurs, okay? And we'll look at, yes, what happens with the other two kinds of soda. And you can be thinking to yourselves as far as how you would change the activity. Notice I'm not saying experiment because it's not an experiment. I know what's going to happen. Okay, I know what's going to happen, and I don't really have many like a variable, a controlled situation. Okay, I am going to change the soda later, but I know what's going to happen, and so it's not an experiment. It's an investigation. Remember, first thing I'm going to do is to open the soda slowly, right? Slowly. Now, my particular bottles of sodas have been sitting for a little while, and so they're not going to already make a mess just by me opening them because we know that soda has gas inside of solution. And that's part of why the Mentos and Coca-Cola react together because I am going to disturb. Can you say disturb? Say it. Disturb. I'm going to disturb the CO2, the carbon dioxide gas that is inside of the soda, the bubbly part, the fizzy part, the part that makes soda so fun to drink. Okay? I'm going to disturb that by introducing a different type of surface for the bubbles to react with and combine with. Okay. Now, my Mentos, I have two. Like I said, I'm only using two. Sometimes you'll see this activity where it's a whole sleeve of Mentos. No, I strongly suggest that you not do that. I do not think the adults in your family will be happy about that. Okay. It will be a big giant mess. Do not tell them that Miss Steph told you that you could use a whole big thing of Mentos like this, because I didn't. Nor did I say you could use a 2-liter bottle, because I didn't. Mhm. I said you can investigate. I did not say you could make a big giant mess in your house. Okay? 1 Mentos, 2 Mentos. Like I said, here are my Mentos. And the Mentos looks like it's this nice smooth surface. Believe it or not, it is not on a microscopic level. It's really rough and bumpy. Let's find out what happens. I'm backing up. I don't want it to get on me. I don't want it to get all over me. Whoa! Wasn't that cool? Wasn't that amazing? Wasn't that cool? Wasn't that amazing? Do you think that the reaction would be different if I used a different kind of soda? Do you think, would you hypothesize that the reaction would be different if I used an old bottle of soda, right? Don't we notice that the amount of bubbles and fizz that are in older bottles of soda is less? Hmm. I wonder, like I said, I wonder. Fanta
What?
next. And who remembers how many Mentos pieces I'm using at a time? Exactly. I'm using two. I'm only going to use two. I am not giving you permission to use the whole package of Mentos because, as you can imagine, based on what we just saw with the Coca-Cola and only two pieces of Mentos, that is a very, very large and violent reaction. Okay. And though scientists get to make messes, we don't want to be ridiculous with it, right? All right. So I'm going to slowly and carefully open my bottle. And like I mentioned earlier, my bottles of soda have been sitting for a little bit, about 2 hours. Okay. And so I'm not going to get this violent bubbling over just by opening the container. But I did get the fizz. Did you hear it? I heard it. And you can try other types of Fanta. There's a pineapple Fanta, there's grape Fanta, all kinds of different Fantas that you might want to try with this investigation. I'm going to add two pieces of Mentos. Wow. Who noticed that the magnitude, and that's a science way of saying the size of something, that the magnitude of this particular reaction was a bit smaller? Okay, was a bit smaller, right? The Coca-Cola one kind of shot up a little bit. And I used, it's the same size of soda, same amount of liquid, okay? And I used the same number of Mentos, and it came from the same container of Mentos. So the likelihood that there's less carbon dioxide dissolved inside of this particular brand as compared to the Coca-Cola brand is very high, right? Because we know that the Mentos pieces and the shell, that hard candy shell that looks smooth but on a microscopic level is rough, is what reacts to the bubbles, to the carbon dioxide contained inside the soda. Go get some Mentos candies, okay? Or maybe you just need to be careful, right? Because you can imagine if I were to put my face really close to this while it was reacting, I could get hurt. It could get in my eyes and everything. And so I want you to investigate these different things, but I want you to investigate in a safe way. Yeah? So, having a great time, everyone. I'm so glad that you joined me for Science with Miss Steph. Yep. So again, using my same procedure, right? Because I don't want to change up certain things if I'm going to have any type of comparison. Though it's not a controlled experiment, I still want to keep certain factors the same so that I can observe what happens, so I can notice the differences, like I did before between the Fanta and the Coca-Cola. Okay? Opening up. Now I'm using Sprite. Who likes Sprite? Hmm? Tell me in the chat. What kind of soda do you like? What's your favorite soda? Does your family let you drink soda? Yay! Here we go. Whoa, so that one was a bit different, right? Did you notice that it kind of bubbled up slowly, but then it went straight up and then came down again? All of these things are so exciting. Oh my. It's time to compare. I think the easiest way to compare the levels would be to remove the label. Amount of soda, right? These are all 20 ounce 20-ounce bottles, right? And though their shapes are slightly different, they have the same basic shape, okay? And um, same type of plastic. This one is green, right? You can see that this one is green, obviously, but it's still clear and you're still able to see the level, okay? Now, the fun thing about the clear beverage, right, is that you're able to see that the Mentos doesn't completely dissolve, right? That's another indicator that it's the shell of the Mentos that's reacting. It's not like an Alka-Seltzer tablet, right? Y'all know Alka-Seltzer tablets dissolve in water-based liquids and it like fizzes and all that type of stuff. But this one, no, it's the shell that reacts immediately. Okay, it's the candy coated shell, that candy coating. And the candy coating, like I said, is on a microscopic level is really bumpy and it is not as smooth as it looks. just to the naked eye is what we call it. Okay. And the bubbles react to the bumps on the candy coating, and it just does what we saw it. Right? Now, back to the mission at hand before we log out today. The mission at hand before we log out today. How much? Okay. And do just draw a little line. I wonder if I have a better marker so that you can really see it. This is, this may seem just simple drawing a line or whatever, but this is what scientists do. We draw lines, we take measurements, we observe the changes. Okay. Now, this one may seem kind of mute, the dark line on the dark soda. But you're able to really tell. I would hope that you're able to tell, that you could see the significant difference between the levels, right? This is a full, I would say, 2 or 3 ounces more still in the bottle, which means that 2 or 3 ounces less came out of the bottle, right? Now, let's look because to me, I'm seeing, whoa, even more, just a slight difference, but that may be because of how the bottles are shaped. This bottle might be a little thicker, I think, here, and therefore they might be even. But see, look, as far as the levels, the same amount of reaction per se happens with these two, with the Coca-Cola and the Sprite. But in the Fanta, there's less CO2 dissolved in the Fanta. The CO2, there must be, right? Because there was less CO2 to react, and therefore less liquid came out. I mean, this was fun. I thought this was fun. I haven't done this activity in a really long time. And last week, when I was doing the Peeps, right, our Easter candy activity, I thought to myself, maybe this month I can stick with kind of a candy theme. So I wonder what candy activity I'll come up with for next week. If you have any ideas, make sure that you post them and tell me about them and say, hey, Ms. Steph, I want you to try this. Yeah, yeah, yeah. I think we had a really great time. Let's review very quickly the materials, the things that are necessary for this activity, for it to be fun and exciting. I used 20-ounce bottles. Okay, 20-ounce bottles. Not too small and not too big. All right. If you use the 2-liter bottle, you are going to need to be pretty much either outside or somewhere like you need to be in it, like it needs to be in the bathtub because the reaction is going to be very, very large and it's going to be a giant mess. I take no responsibility for the mess that happens if you try more than that amount of soda, folks. I mean, hey, you may want to try it, but I'm not encouraging that because it's just going to be a mess. Okay? It'll be fun, but it'll be a big mess. All right? So, yeah, so soda and then Mentos. And for those of you who may not be familiar with Mentos, I just use the plain, what we call the plain Mentos. They are a kind of a mint. They have a hard candy shell on the outside. There is a type of Mentos. There are a type of Mentos that are like a fruity one, and that might be another investigation that you might try. Maybe you use the same size soda, but you instead of changing sodas, maybe you change Mentos. Mm, mm. Or maybe you change the kinds of candy. Okay. Maybe you say, oh, I wonder what would happen with Altoids, even though Altoids aren't really candy, they're just kind of a mint, right? So maybe you try various types of mints. Mm, okay. That could be your investigation. That could move you towards making an actual experiment. Okay. Um, Definitely do not forget the tray. I have my tray sitting down here on the floor because it's got lots of liquid inside of it. And of course, I'll be very careful when I clean it up. But yes, you need a tray or some type of bin, something to catch the mess. You notice how I didn't come with my plate, right? Sometimes when I do the elephant toothpaste demonstration, I just have a plate. This is not plate time, okay? This is you need a bin, okay? Or and you need to be somewhere that can be easily cleaned up. And I'll reiterate, you definitely need to make sure that you have adult supervision and that you're careful to make sure that nothing happens to your eyes. All right. Well, thank you so much for joining me for episode 63 of Science with Ms. Steph. Check out the description box. Make sure you like, comment, share this, and check out the Triple F Empowerment Inc. website to get more information about the upcoming news about Summer Science Club 2021. Registration, fundraising, all that information will be there. Thank you. Until next time.